Todavía no, hasta que yo ahorita le doy clic ya lo uso. Pasándolo entonces.
So we are going to continue with the next presentation. We will be in charge of Sina, Dr. Winyu, and Alidesa Goldman. The name of the presentation is Pso and Neural Network Modeling for photocatalytic mobile pollution in wastewater. So you will have 20 minutes for your presentation, 15 for your presentation, and 5 for any question that maybe they would have. So
the name of this paper is Pso and Nn Modeling for photocatalytic removal of pollution in wastewater. Introduction. The photocatalytic removal of pollution in wastewater has been discussed in this paper. Through computational techniques, namely neural networks and particle farm optimization modeling are developed. A sum of 100 data are used to establish the model. Introductory concentration of dye, UV light intensity, initial dosage of nano AgTiO2, and irradiation time of 4 parameters applied as the input variables and elimination of AY23 as output variables. Materials. 4 parameters to be mentioned as primary dye concentration, UV light intensity, primary dosage of nano AgTiO2, as well as irradiation time are selected as the input variables and eradication of AY23 as output variable. The range of variables which are discussed is summarized in table 1. This is the range of the variables which we have used, and the left-hand side of the table is the variable, and the right-hand side are the range of these variables. After 100 data sets extracted via statistical design related to this study, 80 are utilized in order to train the model. The remaining 20 that were not included in the training are demonstrated in order to test the model. Model results and discussion. In this work, 2 different techniques, NN and Pso, have been applied in order to construct the predictive models for the removal of AY23 in wastewater by implementing a set of 4 operational variables as the estimators. Neural network method. A 3-layer feed-forward back-propagation neural network is used for modeling the UV AgTiO2 process that we have shown in figure 1. This is our neural network, and with input and output and biopsy. The input variables to the feed-forward neural network are stated as follows: initial concentration of dye, UV light intensity, initial dosage of nano AgTiO2, irradiation time per input, and AY23 removal percentage is chosen as the experimental response or output value. The mean squared error, MSE, is utilized as the error function. MSE is calculated from the model predictor and actual measured value of the response variable as this formula. In this formula, Hij and Yj are the model's predicted and measured values of the response variable respectively, as well as N is the total number of data points. Here, the forward backpropagation NN model is laid down to forecast the eradication of AY23 in water. The transfer function in the hidden layer are considered to be linear, as well as in the output layer is taken to be logarithmic. Partial form optimization method. The PhD on the basis of the algorithm is generated in MATLAB environment. Its user-friendly also runs the algorithm for producing the outcomes more effectively with optimal error. One of the primary advantages of this kind of the concept is in comparison to the other global minimization techniques is that the large number of members which generate the particle form cause the methodology implicitly resilient to the problem of local minima. The total process of PSO is illustrated as a flowchart in Figure 2. This is the process of PSO. Result and discussion. Here, different number of neurons are tested from 2 to 16 in the hidden layer. Each topology is repeated 6 times to prevent random correlation, considering random initialization of the rate. Figure 3a and Figure 3b state the relation between the network error and the number of neurons in the hidden layer in NN and Pso model respectively. This is the effect of number of neurons in the hidden layer on the performance of the NN neural network, and this is effect of the number of neurons in the hidden layer on the performance of the Pso modeling network. It can be noticed that the performance of the network stabilized after inclusion of an adequate number of hidden units just above 7 and 6 in NN and Pso models respectively. The network which includes more neurons in the hidden layer can approach effectively. The chosen validated specifications are stated as mentioned below. Where y is the mean of the computed value related to the response variable, the coefficient of discrimination exceeds the level of the variability, or MSE deficit, and average measure of the error in forecasting related to the dependent variable, and the AF exceeds the diffusion of the outcome around the prediction. EF shows the model with which is between -1 and compared to mean square error produced with the help of the Sina model simulation to the variance of the target output sequence. Considering both of the training as well as the validation steps, the model forecasted and experimentally computed values of the Victor of AY23 in water are displayed in Figure 4 and Figure 5 respectively. It simply reveals that the outcomes related from the NN model are in superior agreement along with the corresponding experimental outcomes, taking into account both the cases for training, Figure 2a shows training, and Figure 5a shows the validation. This is our Figure 4a for NN, and this is our Figure 4 for Pso. This is for training. This Figure 4a and b is for training, and Figure 5a is for validating with the method of neural network, and Figure 5c is for validating with the method of Pso model. Result and discussion. The relative importance of the input variables on the AY23 removal efficiency is expressed in Table 2. This is the importance of the variable in the removal of AY23. The importance of this variable has been written in right hand side, and the variable is left hand side. It can be noticed that all variables have influence on the AY23 removal efficiency. However, the influence of AY23 initial concentration in comparison with others is more. So none of the variables investigated in this table could be neglected in the field. As you see that 40 for AY23 initial concentration, that is more. Conclusion remarks. The elimination of AY23 is successfully forecasted by implementing a three-layer neural network along with 7 neurons related to the hidden layer in NN model, as well as by implementing a three-layer neural network in addition to 6 neurons in Pso model. The comparison between the measured and the predicted values in the case of both training and validation shows that NN model outperforms than the Pso model.
Thank you so much. Do you have any questions?
What is the meaning of AY23?
The figure? AY23. That is one material inside the water. That when we have water, there are one yellow color material that is like poison. For cleaning the water, for removing this bad material from the water, that we can become clean, that we can clean the water. This material is not clean from water, and with this method, we can release this material.
Do you have another question? No? Okay, thank you so much. here Carlos Armenta, Daniel Quintana. No? So I think we finish for today. We will come back at a la una. Vale, claro.
Thank you.
¿Ya va a haber otra ahorita?
Pues ya se acabó, porque acababa a las 11, pero no hay, ya no llegaron los de las 10 y 10:20 ya no llegaron, entonces ya terminó
Ok,
y regresamos hasta la 1 de la tarde.
perfecto.